This journey through scale-induced strong emergence and Gödelian unpredictability has unveiled a universe that operates at the intersection of determinism and novelty. From the simplest dynamical systems to the grandest scales of consciousness and cosmology, we see an intricate tapestry of interconnected systems where new laws, structures, and phenomena emerge unpredictably. This emergence is not a mere artifact of complexity, but a fundamental feature of the universe, driven by the recursive interplay of information, matter, and randomness. But how does this unpredictability, this Gödelian spark, ignite the causal engine of strong emergence? The answer lies in scale. As systems grow in size and complexity, they undergo phase transitions, moments when new properties and behaviors spontaneously arise that are irreducible to the sum of their parts. These emergent phenomena, from the cohesion of water molecules into ice to the inexplicable emergence of consciousness in the human brain, are not merely reducible to lower-level interactions. Instead, they exert a top-down causal influence, shaping the very substrate from which they arose. This recursive loop of influence, the hallmark of strong emergence, relies on the same randomness that Gödel uncovered in formal systems. Yet this is no descent into disorder. The universe, paradoxically, finds stability in this chaos. Adaptive dissipative systems, organisms, ecosystems, even human societies, harness the randomness of their environment to extract energy, encode information, and sustain themselves far from thermodynamic equilibrium. Nature's abhorrence of gradients fuels attractor states for these dynamical systems. Landauer's principle reminds us that information is physical, inextricably tied to the matter and energy of the universe, and Ashby's law of requisite variety reveals that any system's ability to adapt and thrive depends on the diversity of its internal responses to external challenges. Together, these principles impose limits on what systems can know, model, and control, but they also illuminate the path toward understanding how strong emergence transcends these limits to create new realities. Gödel's insights into incompleteness remind us that no system, no matter how sophisticated, can fully encapsulate its own complexity. This limitation, far from being a flaw, is the very source of the universe's creative potential. It is the unpredictability at the heart of emergence that allows for the phase transitions and new attractor states that define the progression of complexity, from the quantum world to the human mind. The implications here are that every level of reality is both dependent upon and transcendent of the levels below it. What are the laws of nature below the Planck scale? This theory predicts that there is a deep, potentially infinite hierarchy in the small scale, with reductionistic explanation carving out slices of prediction. Reductionism provides a lens to understand the components of a system, but it is in the holistic perspective, embracing emergence, that we uncover the universe's true depth. By embracing this paradigm, we can begin to address questions that have long eluded explanation. Consciousness, free will, and the nature of life itself may no longer be relegated to the realm of philosophical speculation, but understood as strongly emergent features arising from the universe's deep structure. This understanding not only deepens our grasp of reality, but redefines our role as conscious participants in an ever-evolving cosmos. The future of science and philosophy lies in the integration of reductionist rigor and emergent insight, in the recognition that the universe's most profound truths often arise unpredictably. As we continue to explore, we must embrace the unknown and the emergent, for it is in these moments of unpredictability that the universe reveals its deepest mysteries.